So our next speaker is Martin Schwarz. Martin is an experienced software architect with deep expertise in domain-driven design and hexagonal architecture. He helps teams build maintainable and testable software systems. His topic is applied hexagonal architecture. Let's welcome Martin. Speak now.
Test, 1, 2, 3. Okay, this sounds much better. All right, hello from my side, and welcome to Applied Hexagonal Architecture. I'm glad that you decided for a talk that does not have the AI in its title, and I hope I will not...
Accessibility.
and I hope I will not disappoint. So, who am I? My name is Martin. I'm a software engineer at a Vienna-based consulting company called &AMP. We're doing software engineering and consulting for clients from banking, insurance, public sector, but also smaller startups and just building MVPs for people who have an idea. So that's why I also have experience in enterprise environments, but also in smaller teams. And yeah, sometime in my past I took a wrong turn, ended up studying business, but thankfully I still ended up as an engineer. And I'm curious about all kinds of technology, and the benefit of working in a small team is that you get to experience everything because somebody has to do it. So I have worked on infrastructure with Terraform to backend to frontend to native Android development. And yeah, you learn something new every day. And the reason why I'm doing this talk is that I have worked on 4 different projects that employed hexagonal architecture to some degree and in different implementations. And I learned a thing or two there, and I would like to share my findings with you today. Before we start, a little disclaimer. Doing a talk for an audience with different experience levels is always really difficult. So I try to make it easy for beginners to follow, but I hope that experienced engineers in here will also be able to learn something new. The second, I'm not an authority on the subject, so what you will hear today will be my own opinions, my own experiences. There's plenty of books out there who give definitive answers if you're in need for those. And just for housekeeping, please keep your questions to the end. I think we should have plenty of time there. And I'm also around in the evening afterwards. Okay, so I would like to take you on a journey today. On a journey of the 4 stages of hexagonal architecture. And yeah, let's start. So the first stage, when you don't really know anything about it, then you're in the ignorance stage. So you just take your raw objects from the database, you serialize it to JSON, and then you send it away, and life is good. You don't really care about that. Then somebody new joins your team and is making you implement 3 layers of abstractions, but at the end of the day, you're still only going from database to JSON. Then, so when you're in there, you really hate it, but then at some point, you're wondering whether there could actually be some value in these abstractions that somebody made you implement. And once you move beyond that, you hopefully end up in the embracement stage, and you develop a pragmatic approach on when to use abstractions, and then to only use them when they add value. And once you're there, life is better. So my goal for today is to, if you're in the first stage, is to move you at least to the anger stage, so in the pit of anger, because that, at least then you learn something. Let's see if I can take some of you with me to the embracement stage. Okay, then let's start with ignorance, because to truly hate something, you first need to understand what it is about. So a quick introduction to hexagonal architecture. It was coined, or the term was coined by Dr. Alistair Cockburn. That's how his name is pronounced. My inner child always wants to pronounce it differently, but and this is an actual photo of him, by the way. And it is also called ports and adapters. And he invented the term, I think it was in 2004. And what he said back then about it was that you should create your application to work without either a user interface or a database so that you can do three things. You can run automated regression tests against the application. You can work when the database becomes unavailable. And you can link applications together without any user involvement. So obviously, being written 20 years ago, things have changed a lot. But this is pretty much everything, or this is like the basic minimum that you need to say you're doing hexagonal architecture. Then you have four key components when you're doing it. The first and the most important one is the application core. So you can think of the core of the application as the brains of the application. This is your most crucial business logic. This is where your business value usually comes from. And in hexagonal architecture, if you do it right, this part of the application is completely isolated from outside concerns. Then the next element that we have are ports. So those are entry points into the application. And these are also where we define our use cases, what our application can do. These ports specify the available actions and interactions, and usually they are defined as interfaces. The counterpart to the ports are adapters. So these are concrete implementations of these ports, which connect our application core to the outside world. And it is common to have several implementations for a single port. And coming back to the example, so these would be your concrete classes. And the last important thing that we need is a configuration service, which, when you start the application at runtime, it creates the adapters, injects them into the ports, and just wires everything together. And the good thing is, if you're using a framework like Spring or Quarkus, then you get that out of the box. All right, so that was a brief overview, and I still think that there's a lot of misconceptions about hexagonal architecture, and I would like to take you on a journey to getting to hexagonal architecture by starting something which most of you probably know. So most of you probably know layered architecture or 3-tier architecture or whatever you want to call it, but you have, this is like a typical representation of it, and each layer depends on the layers directly below it and transitively to on all of the layers below it. Since we are only talking about application architecture today, we can forget about the first and the second tier because we're only looking at the backend today. And now I would like to show you how we can translate that to or how we can use that to translate it to hexagonal architecture. So how these layers translate to code, I put a lot of effort in the animations, by the way. So in the presentation layer, you typically think of your typical Spring Boot application. You have your whatever REST controller. In the application layer, you have your service. In the domain model, you have your entity. And then in the persistence layer, you have your repository. And now let's look at how the dependencies flow in such an application. So when you're doing it just like the examples on Spring Boot, then you have something like, OK, the REST controller directly imports the service, and the service directly imports the repository. And everything has a dependency on the entity. And the arrow on the right side, the dependency from the service to your repository, can be a source for pain, because now your business logic that is residing in the service class has a direct dependency on the repository. So the question now is, how do we get rid of the dependency to that repository? And to do that, we apply something that you will most likely learn in university. Many people, or like it's often not fully understood, and also for today, only one principle is really relevant, the dependency inversion principle, my favorite solid principle. And now we will see it in action, how you can do that, or how it works. So coming back, this is what we started out with. For now, we can forget about the REST controller, because the service doesn't depend on it anyway. And to get started, we first introduce an interface. and then we make the repository implement that interface. And this implementation of that interface is dependency inversion. So inverting the arrow that you just saw, that's where the name comes from. So we make the repository implement that interface, and then subsequently, we use that interface in our service. And just like that, we have gotten rid of our dependency on a concrete service. And when it comes to dependencies, then there's two kinds of dependencies that you need to consider. So the first one is what we have now is that service uses the data store, and on the left side, that the repository is implementing that data store. So just whenever you're thinking about dependencies, keep in mind that there's two kinds of dependencies that you can have. Okay, so now that was dependency inversion and solid. So how does all of that translate? Sorry, sometimes the click is flaky and the transitions don't work as I intend. How does all of that translate into hexagonal architecture? And now I will give a really brief introduction to our demo application that we have. So just think of a funding information system that researchers at universities can use to get information about available fundings to them. So we have, this is the system in the center. Then we have the researcher that, okay, the clicker is really flaky. We have the researcher that would like to get information from that system, and we ourselves pull information from external funding providers. So they implement an API, and we get funding data from them. So there's version 1 of the API, then there is a version 2 of the API that we have not implemented yet. And to store everything, okay, I will just use that. To store everything, we just have our own database. And moving everything to hexagonal architecture, so let's start with a use case first. Our poor researcher wants to find information about available funding. And the way that you can then design your application in a hexagonal way is to start with the application hexagon. And as I mentioned in the beginning when I talked about ports, so ports are the entry points into our application, and this is also where we define our use cases. So the boundary right there in green is then where we define our incoming port. And on the other side, we have a use case, an outgoing use case boundary, so for outgoing ports. And there is different terminology what you can call these. So you can also call these driven or primary ports, and you can call the outgoing ports also driving or secondary ports. And yeah, as we can see, like incoming, we have our funding use case, and outgoing, we have our funding data store that provides persistence. Then we learned already that ports are represented via an interface. And then, of course, we need some kind of business logic. So we have our funding service that wires everything together and provides information. However, our interfaces cannot talk with the outside world. So our researcher cannot call our funding use case interface directly. So our interfaces need need concrete implementations, they need adapters. So then on the incoming side, we have something like a funding REST controller, which the researcher interacts with a front-end application. And for instance, for the database, we can use a concrete Postgres funding data store that provides a persistence functionality. And these adapters reside outside of the application hexagon. So the application itself knows nothing about these concrete classes. And yeah, so they interact with outside actors, sorry. They interact with outside actors via a number of interfaces, for instance, HTTP REST for the REST controller and JDBC for the Postgres DB. And then we can, because this is called hexagonal architecture, so we can have several hexagons. You can call, so this is not really a unified standard, but if you need a name for it, then you might choose something like framework hexagon for the outside hexagon. And conceptually, you can also encapsulate your domain entities or really specific business logic into a domain hexagon, but this is not really standardized. Okay, so then we have the first coding example where we will apply dependency inversion. I just made some last-minute changes to the example. I hope I still get it right. Okay. So think of a real minimal application. We have our funding entity. We have a funding resource. So this is Quarkus. It's a resource. It's pretty much just a REST controller here. And we have a funding repository to store stuff. And somebody implemented all the business logic in the controller. So just there's this list endpoint, which calls the repository, which does some really weird stuff. And then it returns that. And you are now tasked with simplifying this or with separating or extracting business logic from that controller. So if you would like to do something like that, then the IDE can really help you a long way. So you can go in there. OK, so it's easier to extract the return value into a temporary variable first. So you can do something like refactor, introduce variable, which is called this temp, because that makes the next step much easier, which is selecting all of that, again, going refactor and say extract method. So now we just call this get fundings. And now this method is already pretty dumb. Ah. Yeah, well. OK, it's back. So now this method is already pretty dumb. I like that. And now we want to move that to a service class. So I can say right-click, refactor, extract delegate. And then I move this to a so-called funding service, and then know that this is a private function that I also want to move over there. So then I just ignore this because I like to live dangerously. And now let's delete this comment. And now this method just calls the newly introduced funding service. So now we have a funding service here. But IntelliJ somehow thinks we should also mount the controller into here. And I don't like that. So let's put something on here and then also just use the repository directly in the service. Then I can say, just call the repository here directly. And just like that, we have extracted the weird business logic that was in the controller to its own service class. But now we are still using, still one thing, but now we are still using the concrete class in the controller. So another thing that we can do now is go to the newly created service, say refactor extract interface, and let's name this whatever now, just let's name this funding use case for now. And we only want this method should be public. And just like that. Oh, no, I actually got it the wrong way. I'm sorry. The concrete class I want to name service. And the interface I want to name use case. Now it's correct. So now our REST controller uses the interface. Interface just has one public method, and then this is our service which implements that interface. And just like that, we have laid the foundation for making this hexagonal. So now I'm not going to do this all the way now, but now you could create your own packages. You could create a ports package, and then you could move the interface into the ports package, and you can move the service into the application package and however you like it. So this is pretty much a really small and simple setup, just using Java packages to get you started. You can also use something like Maven modules or something like that. But if you're just starting out in a small application, packages are probably going to be fine. All right. This was the minimal code example with dependency inversion. So just to briefly recap that, this is what we started with. Our funding REST controller used the repository directly. And this is what we almost did. So we didn't create all the packages. But now we have a funding use case. And our service implements that use case. And our controller now uses that interface instead of the service directly. All right. That was the first stage, ignorance. I hope you learned something. And now that you hopefully understand it, it is time to learn to hate it. So now we're moving to anger. Because each layer can have its own representation of an entity or of a value object. So usually, or sometimes you would like to have something like a DTO that you send to the client. And then to map between your domain object and the DTO, you need a mapper. And this is one thing that I like to help you understand how the dependencies are allowed to flow, because our funding DTO mapper would require a dependency on the funding entity and on the funding DTO. But in Hexagonal architecture, all dependencies must point inward, because otherwise the application core, so our shiny thing, wouldn't know something about its outside world, and it's not allowed to do that. So that's why you need to move the mapper into the framework layer or outside, and then all the dependencies or all the dependency directions are either in the same layer or are pointing inwards, which is totally fine by the definitions. If you then take this to the next step, then you could also have additional entities in the persistence layer, of course also with their own mapper. And now this is where the bad reputation gets from. Because if you remember how we started out, we had 4 classes in the beginning. Now we already have 10 classes or interfaces. And depending on if you would like, if you're doing something like having separate DTOs for create or update objects, then you need representations for that in each layer as well. So now this is already 14 classes. And yeah, this is why some people say, okay, this is super bloated and I don't really see the value in it. So this is why some people hate it. Okay, so is this still working? Yeah. Now that you hate it, maybe, hopefully I can take you to the next step, to acceptance. Because up to now, we have only paid the price for abstractions. So maybe now we can cash in on something, on some of the benefits that we hopefully get from them. So let's imagine that now you have a requirement. We are currently sending an internal mapping ID field to the client. And this is highly sensitive information. We should no longer send this to the client. What we then need to do now, if we have set this up similarly, just let me check out the revision. Okay, so we have still our REST controller, our resource, which returns a funding DTO. And the funding DTO has this field in here. Now, everything that I need to do, or all that I need to do to get rid of this field is to just delete it. And then let's look at the mapper. So I set this up using mapstruct. And in case you don't know it, so if you have 2 objects and they have the same properties with compatible types, mapstruct is able to automatically generate the mapper for that. And depending on how you set it up, it doesn't even complain about missing fields. So if I want to go all in, then I can do something like Maven compile. And that generates the new mapper, where we are no longer setting the field internal mapping ID. And all the changes that just happened were outside of the application core, which I didn't really have to touch. So this is one way how the separation of these layers, or how the separation of these concerns really helps you to just react quickly to changing requirements. Now, for a second example on how this could help you. How are we looking with? How much time do I have? Sorry.
We have about half an hour.
Okay, then we're still good. So now imagine that I just, in the beginning, I showed, okay, there's 2 versions of the API, and now they want to deprecate version 1 of that API, and we are advised to migrate. So we're just going to do this on the slides for now. So this is what it kind of looks like. So we have our outgoing port called external fundings, and we have our REST client that gets information from the funding API version 1. And if we now need to migrate to the second version of that API, all that we need to do is provide another adapter that implements the exact same interface. And so this, of course, assumes that there were no new requirements on like which fields to use or something like that. But you should, for most cases, you should be able to accommodate that changes. And then you only need to implement that same interface, map it into your funding domain object. And again, you would not need to change a single line in your application core, which can continue working as it did before. OK, so these were my 2 examples. I hope that there is now some acceptance there. So now I can hopefully transition you to embracement. And this is just where you need to build your opinion on how you want to go about this stuff. So there is always a gap, or like this is an important thing to consider, whether you should follow rules dogmatically or whether you should develop your own pragmatic approach. So on the left side of the bell curve, you might have somebody saying, yeah, whatever, I don't know any better. I would just use the repository directly in my controller. And then as you learn more and more about rules, and then you maybe read clean code, and then you might end up becoming that person which is really dogmatic about rules and says things like, oh, you didn't follow my guidelines. You are never allowed to use that. You should always use mappers between these objects. And so this is just a really dogmatic approach to that. Whereas on the far end of the bell curve, you might actually end up with doing something like that, because you weight all the trade-offs. You know, okay, all of these abstractions, they also cause a lot of mapping, or they also cause a lot of overheads to actually make changes then. So for this use case, for now, I think it could be fine to just do that. And that's the one thing that I want you to take away from this talk, is that there are many ways to achieve your goals. But you need to be in the driver's seat, and you need to be aware of the consequences of each of your decisions. So the left side of the bell curve, he just didn't know any better. And the other side of the bell curve was like, OK, I know the implications of doing that, and I accept the trade-offs for now. So just think about that when you're making decisions, and don't become a victim of accidental architecture. Another thought is that abstractions are not free, but tooling can make them cheap. So you saw I used some refactoring tools of my IDE, which provides really great support. Mapping frameworks can help you get rid of a lot of boilerplate code. You can use code generation. For instance, the OpenAPI code generator is a really great tool if you have several layers. Static code analysis, Arc unit tests can help you to enforce your boundaries in the CI pipeline. And there's a lot of other examples that can help you to make the cost of abstraction less. Another thought is about how strict your rules should be. So on the left side of this hexagon, we have like a typical request flow from REST controller to the data store. And on the other side, we have like a really direct flow, just the REST controller using an interface of a data store directly. Because if you tend to have really strict architecture rules, then you might up with something called lasagna architecture, where you're just implementing objects and layers and services to satisfy your architecture rules. And this is a code example from an actual project that I've seen, which is just a class that implements an interface, and all it does is proxy the calls one-to-one to another class. So this was just really implemented to satisfy the architecture rule, to satisfy the arc unit tests, but it doesn't really add any value. So I think when I'm seeing something like this, then it's maybe time to reconsider your rules, because maybe your application is not as complex as you thought in the beginning. One proposed benefit of hexagonal architecture is that you are able to test every component in isolation, which sounds really good on paper, but it also has drawbacks, because then your tests tend to be tightly coupled to the implementation. Depending on how you do it, you might have to use a lot of mocking or stubbing, and it can end up with having multiple test configurations. And for what probably 80–90% of the web developers are working on, which is their standard CRUD REST API with role-based access control, I personally think that you're better off with a decent set of integration tests and unit tests only for complex business logic. Okay, and wrapping up, final slide. When does hexagonal architecture shine? So I think it shines especially when you have multiple external dependencies. So if you're consuming a few APIs from different teams, and also maybe the collaboration between the teams is not that great. So that means you have little control over the dependency. Using something like hexagonal architecture can help you build a protection layer around these external dependencies. It also shines when isolation of application logic is critical. So we use that extensively when migrating a really old legacy application, where it was really tempting to just pretty much rewrite the existing logic in Java, but then you end up not fulfilling your goal. So by isolating the application core from the old logic, it just helps you to put a barrier between the old code and new code. And using hexagonal architecture, it can also act as a kind of anti-corruption layer between the service that you're consuming. It also shines when strict modularization of the application is desired, because when you enforce proper boundaries early on, it will be much easier to carve it into smaller services later on. And I think the most important benefit that you get from it is that it provides a common language and a common structure. So when you're in a team and you're speaking about dependency inversion, or better example, if you're speaking about the tasks of an adapter or the tasks of a port, then everybody knows what is meant by that if we agreed to have hexagonal architecture. And also it allows enforcement of architecture guidelines, for instance, using arc unit tests. Okay, I think that's it. I hope I moved some of you into the embracement stage. I kind of already wrapped up with the last slide. So that was it from my side. This QR code leads to my LinkedIn. I would love it if you reach out and connect. This was actually my first time speaking at a conference. So if you liked it, please let me know about it. If you didn't like it, especially let me know about it and tell me what I can do better. Yeah, that's it. Thank you.